Hello and welcome to another video. In this problem, we're going to be working on remove colored pieces if both neighbors are the same color. And so to sum this up, pretty much, you have an array of colors, and every color is a letter A or B. And there are two players, Alice and Bob. Alice can only take A's, but she has to take A's that are surrounded by A's. And Bob can only take B's, but he has to take B's that are surrounded by B's. And they can't remove pieces from the end of the line, like I said, because in order to take a piece, it has to be surrounded by two of the same letter, as it shows here. Alice is only allowed to take A if the neighbors are A, and same thing for Bob. So let's kind of walk through these and figure out what would happen. And essentially, if you can't make a move, you auto lose. So you just keep playing until you can't make a move, and then when you can't make a move, you lose the game. So for this first example, let's actually draw it over here, maybe. So we have A, B, A, B, B. So if we just look at like what letters are even available to take, for Alice, it's only this letter over here, right? Because Alice can only take an A that's surrounded by A's. This is the only one. And there are no letters available for Bob. He needs B's that are surrounded by B's. So Alice would just take this A would go away, and then Bob can't take a letter. So Alice would win. Now let's go to the second example. So in the second example, we have AA. So in here, there are no A's surrounded by A's or B's surrounded by B's. So Alice can't make a winning move, or Alice can't make a move at all, and Bob can't make a move at all. But because Alice always goes first, Alice would lose. So Alice would try to make a move, can't, and it would lose. Okay, now we have another example. We have A, and then we have 6 B's. So B, 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 and then we have AAA. So if we look for letters for Alice that are available, it's only this one. And there are a bunch of available B's, right? So there's this one, this one, this one, and this one. So what would happen is Alice would go first. Alice would have to take this letter. And then Bob can take any one of these. It doesn't matter. Let's say you just take the first one. Then Alice has no more letters, and Alice would lose. So that would be this example. So pretty much the trick to this problem is to realize, like, let's take a look at this. So we can only take letters that are surrounded by the same letter, right? So the only available letters in this case are these letters and this letter here. And so if you just notice, you can only take letters that are in like one long chunk. And if you take them all, the state of what letters the other person is allowed to take will never change. So we can keep taking B's, and then the state of A's will never change because these B's have to be surrounded by B's. So after you take all your letters, these two will still be B's, so you're not affecting anything around you while taking letters, essentially. Like, you're always taking letters from a group of 3 or more, right? In order to take a B, there have to be at least 3 B's. And so when you take one, the surroundings are still the same. So the state is still pretty much exactly the same. So essentially, all you really have to figure out is how many B's are there allowed to take, and then how many A's are there allowed to take. And the order you take them doesn't matter. It's not going to affect anything because you're never changing the state. Like, you don't need a stack or anything. You can never get rid of like the last B or the last A or any of that. So it's literally just a question of how many B's are available and how many A's are available. So like in this case, and how do we figure out how many B's and A's are available? That one's pretty straightforward, right? All we would have to do is go letter by letter, starting with the second letter and go to the second to last letter. So we go for like this thing. And then all we have to do is compare the letter to the neighbors. And if it equals its neighbors, it's available to take for someone, right? So like we would check this B and we'd say, is it equal to both its neighbors? No, it's not. Is this one? Yes, it is. And then if it's a B, then it's a letter for Bob. So we just have like an Alice and a Bob, essentially. And so we can kind of color these. So this B is equal to its neighbors. This B is as well. This B is as well. This B is as well. That's 4 letters. And then you just check like which letter is it, since they're all B's, that they would all add to Bob's availability here. So Bob would have 4 letters. And then this is the only letter that Alice can take. So this is equal to all the neighbors around it. And this is an A, so that Alice would be 1. And then essentially, once you figure out how many letters are available for Alice and Bob, it's really easy to figure out the winner. Because Alice has to go first. So let's think of like the scenario. So if Alice's score is less than Bob's, Alice has to go first, so obviously Alice will lose. right? What if Alice's score is equal to Bob's? So since Alice has to go first, Alice will lose again, right? Because like let's say Alice has 4 letters, Bob has 4 letters. It would go Alice, Bob, Alice, Bob, Alice, Bob, Alice, Bob. And then these would all be 0. And then Alice would have to go first, so Alice would lose. So if the letters are tied, Alice loses. If Alice has less letters, Alice loses. So for Alice to win, Alice has to have more letters than Bob. And that's pretty much all you do for this problem, is you literally just look for available letters, you add them to the person they're available for, and then you just see, is Alice's count greater than Bob's? If yes, Alice wins. If not, Bob wins. And the only tricky part is to realize that when you take, first of all, the order of the letters you take for each person doesn't matter, because you're not changing the state. And no matter how many letters you take, you're never changing, like, you're never giving the other person more letters to take by taking your own, essentially. That's kind of like the crux of it. Whenever you take letters, if Alice takes letters, there are no like more available letters for Bob, depending on what Alice takes. It's not like some other of these algos. It literally doesn't matter at all. Like you're basically playing, you know, your tiles don't affect the other person. So that's pretty much it for this actually, and now we can code it up. So there's a few ways to do this, but I'm just gonna code like the really easiest way, and the time complexity will be the same for all of it. And as far as like as far as how fast it runs a LeetCode, because this is such a small algorithm, like a bunch of small things are gonna actually affect that, which isn't super important, right? Because it's only you're only gonna have like a couple variables, and it's gonna be an o(n), not a function. So I'm just gonna make a score for Alice and a score for Bob. And then essentially we have to loop through every single letter in colors except for the first and last letter, because the letter has to be surrounded by letters just like it. So the first and last letter can't be available letters. So we can just say like for char something in range. In range. And then we're going to start at I, and then we're going to end at length colors -1, because we don't want to look at the first and last letter. So pretty much the character has to be equal to the letters around it, right? To the one before and the one after. So we can just say like if colors char -1. And like I said, there's a bunch of ways to do this, but essentially once you figure out what you need to do, the algorithm part of it, the coding part of it is really easy. So if this is equal and this is equal, if these are all equal, then this is a letter for some person. So we just have to figure out what's the letter now. So we can just say if colors char is A, let's add to Alice. Otherwise, it's a B, so then we'll add to Bob, because it has to be only A's and B's. And then finally, when we do that, now we have a score for Alice and Bob, and all we have to do is return Alice is greater than Bob, because in order for Alice to win, Alice has to have a greater score. And that's pretty much it. So let's see. There we go. Okay, and then as far as efficiency, like I said, it's all over the place because it's just such a small function, like not a huge deal. It's reasonably efficient. So let's go through the time and space for this one. So essentially we're looping through every character and we're comparing it to the character to the left and to the right. Like I said, you can technically make it more efficient on LeetCode if you want to, because you are doing a few redundant checks, but that's whatever. So essentially, to compare every character to the character to the left and to the right, it would be like 3n, right? Which just simplifies down to n. And yeah, and then we also do this part, which is O1. So, and for the space, we only made an Alice and Bob variable. We didn't make anything extra. So this is just going to be O1 space. And yeah, like this problem is pretty straightforward once you realize kind of like there is no trick to it. I feel like most medium problems, if you try to do it like this, if you're like, oh, I'll just count all the available letters and not think of anything else, then you usually get a test case that kind of shows you like, no, there's like a bunch of other things you need to consider, a bunch of edge cases you need to consider. But in this case, there aren't any. So yeah, it's going to be all for this problem. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.